Okay, we're coming up on the end of this, but we are now on exercise 5 in paper 2. So let's walk this one through. So let f of x be equal to 2 minus x squared, and let g of x be equal to ln x for x larger than 0. Okay, so in both cases, we're automatically going to assume that we're only interested in x's that are bigger than 0. We're not going to look at negative x's. Okay, well that seems fair enough. Anyway, the first question is to find f dot gx. Well, what does this notation mean? What does it mean when they write f dot g? Well, what that really means is f on the outside and g on the inside. So it would look like this if we rewrote it to be perhaps, or well, at least more in the notation that I tend to use. And if we look at that, we go, hey, wait a minute, this is just composite functions. We know how to do that. That's easy peasy. So that's exactly what we're going to do. We're just going to composite these two functions together. F goes on the outside, so we do 2, and then we do minus, and then in here, we're going to write g of x, and then we're going to square whatever it is. So I'm going to write g of x instead of x, and then I'm going to write squared. But this is the same thing as 2 minus ln x, then squared. This is exactly the same thing. So that right there, this is actually our answer. It's that simple. And this is one of the rare cases where I can actually explain it in the time that it would actually take you to do this in the exam, or that it should take you to do it in the exam, because ideally, every mark should translate to about a minute of working and writing. Not necessarily always the case, but ideally. Let's take a look at B. Solve the equation f dot g of x equals to x. What does that really mean? Well, it basically tells us I want to solve a problem that looks like this. And let me just finish it up. There we go. Oh my god. Sorry, I keep getting interrupted by a program I don't really want to be using right now. So that's the only thing that's bothering me, but that's okay. So this right here, this is what we want to solve. We want to solve this. Now, how are we going to solve this? The simple answer here is not by way of isolating, not by way of making any complicated inferences, none of that. We're going to go to the reason this is on the paper too, the GDC. We're going to go straight to that. All you have to do is, and I'm going to do this the way that I would normally do this in an exam, all you have to do is go in and try to graph both of these functions. So for instance, I could graph the function 2 minus ln x squared, which will take a little moment, but I'll try and see if I can't get it working. And of course, and then I could also graph the much more simple function of just x. And then we can simply try and see if we can figure out when they cross. Now, I'm going to quickly set up there we go. So now, I'm going to take a picture of it. This is what it looks like. And all I've done here is I have graphed a red function by basically writing in this. I've written f of x equals to x. Then with the blue one, all I did was I said, well, let's use another f of x, and let's call the one 2 minus ln x. And then I took the square of that whole thing. So I put a little bracket around everything. And then I said squared. And then it gives me both of these. And I can see very clearly that there's actually two solutions. There's this one and this one. On this question, because it wasn't very clear, I've actually given points even if you only found one solution, but in principle, if there are multiple solutions, you should always try to find both. You should always try to find both and write both down. This is why I recommend graphing. I recommend graphs because graphs show multiple solutions. You can use NSolve here, but it only gives one solution. So this is something to keep in mind. It's not necessarily a problem that you use NSolve. It might even be good. There are many nice things about NSolve. One of them being that you don't have to figure out where the intersection happens at all. You don't even have to look around or goof off with the graph. You can just go NSolve and then you get an answer. The problem with it is that it might not be the only answer. That's the one thing that you must keep in mind when you use NSolve. This is the big hurdle with using it. So basically your options are you can use NSolve or you can use graphs. Either one works. Now again, how do we find these two intersections? Well, on the calculator, we use menu, then we go to analyze graph, and we look for intersection. Once we are in analyze graph and intersection, we can select the lower bounds that we want. I'll show you where you find this command. Let me just... There we go. So the place that you can find this command is in here, where you go down into Analyze Graph, and then you simply go ahead and you pick intersection. This will find where two graphs cross. Okay. But with that in mind, you get your two solutions. Now I get them to be 0.26. That's one of the x's that works. Remember, we're looking for solutions to x. And the other one is 1.71. Okay. So these are apparently the two numbers that will work. That's interesting. So now the next one is hence or otherwise, given that g of 2a is equal to f of minus 1 of 2a, find the value of a. So there are basically two ways to do this. The first way is, well, you could look and you could try to find f minus 1. And that's quite simple because f right now is, let me show you, f right now is 2 minus x squared. So right now this is what we have. If we were to invert this, we would have to swap this to be x and this to be y. In order to isolate for y, all you would have to do is you'd have to have 2 minus x. That would be equal to y squared. I hope that that so far is agreeable. Then you must take the square root so that it would be 2 minus x. This right here is an appropriate inverse solution. However, you don't even have to do this. This is technically speaking not necessary. You could take this and then go, okay, so square root 2 minus x equals to ln x. And then you can go further and say, okay, well, 2 minus 2a. How about that? And then equals to ln 2a. How about that? And then solve this with NSolve. This is totally a reasonable solution. This is a fine solution. So I'm going to write down here, this is a fine solution. However, there is a more subtle way to solve this problem, which I think is interesting and worth pointing out. So pay attention to this. We've got here g of 2a equals to f to the minus 1 of 2a. What happens if we wrap both functions in f, as if, like this, for example, f of g2a, and then on the other side, we have to do the exact same thing, so we do f of f minus 1, let me make that bracket a little bit nicer, of 2a. Well, if we wrap them like that, remember your inverse functions. What happens when you use the function on the inverse? it just disappears. You just get this. Now look very closely at this. Does this look in any way familiar? Does it look like, what happens if we were to take this part, replace it with x, and replace this part with x? That's right, we get right back to where we were before. We are basically still looking at a case that is like this, equals to x, just like we did before. The only difference is that 2a is equal to x. And then what we can do is we can go, well, if that's true, then the x's from before, if we divide them by 2, they'll give us our a. So really, our solutions are just going to be these divided by 2. So it will be, and let me try and do this on the GDC to make sure I don't make a mistake. 0.268 divided by 2, I think that's it, yeah. It gives me 0.13. 1, 3, 4. This would be one of the a's that will work, I should say. One of the a's that will work. And of course, the other a should then be 1.71 divided by 2, 0.855. Okay. So 0.855. This is the procedure to solve this one. At least this is the procedure that I like. I like this solution because less work. It's more theoretical, and it does require that you understand the concept of an inverse function very well, and very, like, in a somewhat complicated way. And again, I want to emphasize here, if you don't like this one, if you think this is too hard, if you think that this whole solution made no sense, then as long as you understand this solution, it's okay. I don't mind. This solution is for people who really want to save time, and for people who are very good at the conceptual side of math. But if you aren't, if you just like to do the more executive part, where you just sort of, okay, here's a problem, I need to solve it, then use this one.